first in a couple of series of videos I'm going to make about special right triangles. So, we have two kinds of special right triangles that we usually talk about. One is a isosceles right triangle, or what's called a 45, 45, 90 right triangle. Okay, so 45, 45, 90 right triangle. We have a 90-degree angle, we have our right angle, and then we have 45 degrees, one acute angle, and the other angle is also going to be 45 degrees. This is an isosceles triangle, right? These angles are the same size, so we know that this side also going to be the same size. We can use all that to find out some stuff. So, for instance, if I call one of the legs here, one of the shorter sides, A, well, I know that if this is A, then these are the same size, so this is also A. Whatever length this is also. And I can use the Pythagorean theorem, right? A squared plus A squared is going to equal my hypotenuse squared. So A squared plus A squared, 2A squared. Okay, and then I'll take the square root of both sides, and I get C equals A, I'll do it this way, 2A squared, square root of 2A squared, which is A times the square root of 2. And square root of A squared is A, square root of 2, square root of 2. That tells me that anytime I have a 45, 45, 90 triangle, right, any triangle, I've got a right angle, I've got 45 degrees in one, I've got 45 degrees in the other, that if I know what this side is, if this is my A, then I know this will be the same, this leg will be the same, the legs will be the same, and the hypotenuse will be there, whatever this length is, times the square root of 2. So for instance, if the length is 5, the leg is 5, the hypotenuse will be 5 times the square root of 2, and so on. The other type of right triangle that I have is a 30, 60, 90 triangle. Now, I'm going to go show this how this works. I'm going to actually start with an equilateral triangle. Say that this is equilateral. Okay? Now, if I have an equilateral triangle, that means that each of these angles is 60 degrees. Because the equilateral means also the angles are the same measure. They have to add up to 180 degrees, so they're each going to be 60. Then I can take this triangle, I can take an altitude, drop it down from the vertex in the top. That's going to bisect this angle at the top, and it's going to bisect the bottom side, base of the triangle. When I do that, I end up with, well, I end up splitting this angle in half, right? So this is 30 degrees, and then this will be 90 degrees, 30, 60, 90. Now I have my 30, 60, 90 triangle. Well, if I say that the whole side of the triangle is 2A, let's say why not just A? Let's see why in a second. If this is 2A, well, I know that this side also is 2A, right? Okay, and I know that this altitude that I dropped down here bisected the base, so that means that this is half of 2A, so this side here is A. So I'm looking at this triangle here, and I'm just going to redraw it over here. So I've got 60 degrees, 30 degrees, right angle here. I've got A on this side, and 2A on this side. Let's just look at what we've got. We've got two legs. One is short, across from 30 degrees. One is longer, that's across from 60 degrees. And I have the hypotenuse. I know this side and I know this side. I can use that Pythagorean theorem to find the third side, the longer of the two legs. So I know that A squared plus B squared equals 2A squared. And then I know that A squared plus B squared equals 4A squared. Subtract B squared from both sides. B squared equals 3A squared. Take the square root of both sides. I get B equals the square root of 3A squared, which is the same as A times the square root of 3. So I'm going back to my triangle here. And B is A times the square root of 3. So that tells me that whatever I know about this triangle, whatever the length of this shorter leg is, the longer leg will be that length, A, times the square root of 3. And the hypotenuse will be that length, A, times 2. I can use this anytime I see a 30, 60, 90 triangle. Just like I can use this pattern every time I see a 45, 45, 90 triangle. All right, in the next videos, I'll start going over some examples and how we can